Hello, for this screencast, we're going to walk through one of the items from the textbook, namely the progress check 8.8 on page 160, which deals with probability and specifically conditional probability, which can at times be a fairly complicated problem. So hopefully this will help you find strategies to set these types of problems up and to solve the problems moving forward. So for this progress check, they talk about 100 couples had undergone marital counseling, and they provided some information about these 100 couples. Namely, they mentioned that of the 100, 60 of them reported that they had improved relationships after the counseling. And they mentioned also that of these 60, 45 of them had children. And then they also mentioned about how of the remaining couples that did not indicate improvement and that there was no improvement, of them, five of the remaining had children. So what I set up here was a flow chart or a tree diagram going left to right that breaks up the information, all the possible outcomes that they've given us. And what I have in blue is the actual information they gave us, and in green is the information you had to deduce from what they left out. So again, we had 100 couples. They told us that of them, 60 of them found that there was an improved relationship. So the remaining 40 ended up not. And again, of these 60, 45 of them had children. So therefore, the remaining 15 did not have children. So in green, I deduced that since 45 out of the 60 who found improvement had kids or children, then the remaining 15 did not. And then, like so down here, I knew that 60 of the 100 found improved relationships, then the remaining 40 did not. And of these 40, we knew that, and they told us that 5 had children. Therefore, then the remaining 35 do not. So before I started answering any of the questions or even reading any of the questions for this prompt, I set this table up, or this tree diagram. And I highly recommend you doing that for these problems. So now that I have this completely set up and all the possible, in this case here, there are 4 possible outcomes of categories of people selected. So if I were to randomly select somebody in this study at random, then I'm going to get either somebody who found improved relationships and had kids, or improved relationships and did not have kids, or did not feel that they have improved relationships but had kids, and not improved relationships and no kids. So there's 4 possible outcomes here, and these should add up to 100 if all of our situations are what's called mutually exclusive. For example, you have children or you do not. So those two are mutually exclusive. So this adds up to 100 so that I know I have all 100 participants accounted for. Now let's walk through the problems that they've asked. The first question was, if you were selecting a couple at random, what is the probability that their relationship was improved? So from there, we could extract that straight from the information given. 60 of the 100 felt that they were improved. So I set up a fraction. In the numerator again, we always have our favorable outcome, which is what we're kind of shooting for in the question. So in this case, there were 60, but out of all the possible selected, there was 100 possible couples selected, so 60 out of 100. You could reduce this fraction, for example, to 3/5. However, it would be good practice to start transitioning everything into decimals, and our probabilities should always be between 0 and 1. 1 meaning it's a certain event, that it's guaranteed that it's going to happen. 0 meaning it's an impossible event. And for most of the problems, it's going to be somewhere in between. So 60 divided by 100 converts over to 0.6. I recommend you not get in the habit of writing 60%. They're not asking you what percent of the population. They're asking you what's the probability of a certain selection. So 0.6 is the answer there. Then we're going to go down to the next question. They ask what's the probability that a selected couple has children. So notice here it's out of all 100 we're talking about. So the denominator is still 100, but there are two possible situations that have children. Either these 45 out of the 60 improved, or these 5 out of the 40 who felt no improvement. So I add the 45 and 5 to get the numerator of 50. So of all 100 couples, 50 of them had children, which then converts to a decimal of probability of 0.5. Now the next 3 questions are the ones that are a little more complicated, and I personally find that these tree diagrams help tremendously. Otherwise, if you get lost in the weeds of some of the formulas, it can tend to be difficult. So for part C, they asked, what's the probability, what is the conditional probability of randomly selecting a couple with children, given that their relationship was described as improved? When they use the term given that, that's setting up to say, okay, I'm not talking about the entire population of 100 couples now. I'm talking about what's the probability of just the ones that marked improved. So in this case here, our denominator is going to be 60. So we are saying out of the 60 who we know indicated improvement, what's the probability that they have a child? So it's going to be the 45 out of the 60 rather than 45 out of the 100. I tend to use this little symbol here of the slash, and the textbook does it ×2, where I have the initial, again, favorable outcome, the probability that they have a child, given that it's out of the population of those who felt that it was improved. So it's out of a smaller group now. So 45 divided by 60 gives me the 0.75. Next question, part D, asks, what's the conditional probability of randomly selecting a couple without children, so no children, given that their relationship was described as not improved? So no children, given that not improved. So now my population that I'm drawing from are just the 40 that indicated no improvement to begin with. And of these, 35 of them do not have children. So my fraction now is 35 divided by 40, which converts to 0.87. And the last question, what is the conditional probability of an improved relationship, given that a couple has children? So now we're actually going to work through this a little bit in reverse. We're saying now, what's the probability that it's an improved relationship if we already know that they have children? So it's not just out of this group here, it's out of the 50 that have children. Of these 50, how many of them felt that it was improved? So it's 45 out of the total 50, which gives us that fraction of 45 over 50, and a decimal probability of 0.90. So hopefully that helps walk through this. Again, a few items to highlight. Number one, this tree diagram is a tremendous help for making sure you have all the information laid out. Number two, when you're dealing with conditional probability, our textbook pretty much says it up front. They use the terms conditional probability and the expression given that. So that given that is leading to what is the denominator. So I usually, again, always set these problems up so that I have what I'm looking for, or the favorable outcome, and then given that, the new smaller population of the group that I'm focusing on. And then the last point is this. Our answers for probability should tend to be in decimals. And let's remember now, these decimals need to be between 0 and 1. You should not have a decimal value of 1.5 or anything like that, and we shouldn't be getting negatives either. So probabilities always have a decimal of between 0 and 1. All right. Hope this helps. Thank you.